Hello, and welcome to Key Stage 4 Chemistry topic, the Chromatography and Rf Values, and this is a required practical. Before we get started, can you please make sure you have a pen, paper, pencil, ruler, and a highlighter or another coloured pen and pencil for self-assessment. And can you also make sure in a quiet room, no distractions, no other technology to distract you, and make sure we focus on this learning enhancement video. Can you now take down the learning objective to know how to calculate the RF value on chromatograms? It's 10 seconds just to get that down. Okay, so retrieval practice is on the screen now. Can you please have a go at these 4 questions, and I'll give you 4 minutes for that. So 4 minutes, have a go now. Okay, your time is up there, guys. Your 4 minutes are up. Can you please make sure you've got a green pen or another coloured pen and pencil to self-assess these 4 retrieval practice questions? So, question 1, give an example of a pure substance. Now, the answer for this is very broad and general. So, if you just put down any example of any element or compound, so any elements found on the periodic table, such as oxygen, hydrogen, nitrogen, carbon, and so forth, or any individual compounds such as carbon dioxide, so CO2, or H2O for water, or NaCl, that would have been absolutely fine. So give yourself a mark for that, for any element or a compound, because they are a chemically pure substance. What is a formulation? So a formulation is a mixture that has been designed as a useful product. So useful products, often fertilizers, are the most common example, a mixture of useful elements for plant growth. Question 3, what do we use chromatography for? So this is all about today's learning enhancement session. Separating a mixture of soluble substances such as inks or dyes. Keyword there, soluble, that means it can dissolve within, it can dissolve. And question 4, why should lines be drawn in pencil when doing chromatography? So this is taking a step back to key stage 3. This is so that the pencil will not affect the results, as it is not ink and will not run when water moves up the chromatography paper by capillary action. So give yourself a mark out of 4 for that, guys. Mark out of 4 there. Excellent if you got 4. 3, very well done. 2, good. 1, let's add in the improvements just there. Okay, so learning outcomes for this learning session today. I'm going to explain how paper chromatography separates mixtures, so the theory behind chromatography. Describe what happens to pure and impure substances, and then interpret chromatograms and determine RF values from chromatograms. RF also stands for retention factor, just to make you aware of that. Okay, so just a bit of a recap, chromatography. So why do samples travel further than the others? I just wanted you to, as a starter, jot this down on a piece of paper or in your book to answer the question, why do some samples travel further than others? Used in a diagram to help you as well. 1 minute, go. Okay, your minute is up there, guys. So to answer the question, why do some samples travel further than others? Well, separation depends on the amount of time substances spend in the mobile and stationary phase. So mobile means it can move, of course. Stationary, that's often the paper, and when it's not moving. Ink that travels towards the top has a greater attraction to the mobile phase, the solvent, which is the water, and then ink that stays near to the starting position has a greater attraction to the stationary phase. So to simplify that down, the smaller the ink particles, the further they travel. The bigger the ink particles, the larger they are, they don't travel as far because they can't dissolve as much and pass through the stationary phase of the paper. Okay, so give yourself a mark just for that if you got it down. If not, add in any corrections just there. Okay, so this is a common GCSE exam question. You are given 3 different samples and they're often not in colours shown, often in grey or the same colour, grey or black, or sometimes white as well. So what the results tell you about the brown colour and its suitability for use in sweets? If you're at school, please have a discussion about this in the class now. If at home, have a think And then I want you to try and answer the question, a bit of recall here. It is 3 marks, so we're looking for 3 points. I'll give you 4 minutes for that. Go. Okay, 4 minutes up for that, guys. Hope you had a little discussion and then had a go at answering this GCSE exam question. So to answer this, what results tell you? So any 3 from these possible one, and you will, if you mentioned a dye for colour, that would be accepted as well. So it's made up of 2 colours or 2 dots. That's one point there. If you mention that, made up of 2 colours. Contains an unknown colour as well, the dot. There's an unknown one. Contains a harmful colour because it is banned. If you look at the top line, because it is banned, harmful. Contains E104, which is quinoline yellow, or does not contain the brilliant blue. One of those. And further analysis is needed. Further analysis is needed because it's inconclusive. So give yourself a mark out of 3 for that. Excellent if you got 3. 2, well done. 1, let's add in just those corrections there. So this is a common GCSE question, and it's often asking you to compare the differences between different colours and different dyes of different samples. So this is just a recap. You can pause the video to get this down. So chromatography can be used to separate mixtures and can give information to help identify substances and compare, often comparison. So I mentioned earlier the stationary phase and mobile phase. So on the diagram, the stationary phase is often the paper, the chromatography paper, and then the mobile phase is the water, or the solvent, which is obviously the part that moves and then carries the ink within it. And then separation depends on distribution of substances between the phases, between these 2 different phases. So hopefully you've already got that diagram drawn in. If not, can you please draw in the diagram there and then label the stationary phase and the mobile phase, and then have a go at the questions below. Why is there a lid on this example shown? And then why is the start line above the solvent? Okay, so I'll give you 5 minutes for that. 5 minutes to make sure you draw in the diagram, label with the correct labels, and then answer the 2 questions below. So 5 minutes, go. Okay, your 5 minutes up there, guys. Can you please make sure you've got another coloured pen and pencil now to self-assess these? So, start off with the stationary phase. That is, of course, the chromatography paper here, so just labelled there on the right-hand side. And then the mobile phase is, of course, either water, which is a solvent, or the ink if it is insoluble, which is often used ethanol instead. So ethanol is often used instead of water if the ink is insoluble. But you will always be notified of that in the GCSE exam. There is a lid on this example here because it just simply stops the solvent evaporating. Often you have to leave these for maybe a day or so just to show the true effect, and that just make sure it doesn't stop the solvent, the water, from evaporating. That's why there's a lid on that. And then why is the space between the samples so they don't merge, and so the solvent and the ink do not just run into the solvent and then cause a void result. And then also just be aware of it is in pencil as well, the line, so it doesn't smudge as we've done in retrieval, just to make you aware of there. So give yourself a mark out of 4 overall, so 2 for the correct labelling and 2 for correct question answers. Give yourself a mark out of 4. Excellent if you got 4. 3, well done. 2 and below, let's add in the corrections there. Okay. So another quick question there, it's just a bit of a recap. Which of these is a pure substance and which of these is a formulation? How do you know? So you can write this down if you want, have a little think, give yourselves a minute just to have a think, a little discussion to answer that question. How do you know which is which? So hopefully you had a nice little discussion there. So pure substances will always be one spot in any solvent. So A is a pure substance because it's only one colour, it's only one ink, it's only one. Whereas mixtures may separate into different spots in certain solvents because they have different colours and different inks. That's the difference between them. So A is pure substance, B is a mixture. Okay, so now I'm going to move on to the bit more challenging calculating RF values. Remember, that is retention factor values. Before we get started on this, can you please make sure you copy down the 2 bullet points and in particular the calculation for RF values, the distance moved by substance over, that means divide, by the distance moved by solvent. So can you get down the 2 bullet points and calculation? Okay, so an example here, I'm going to go through an example progress check and then you guys are going to have a go yourselves. So we've got RF equation at the top, so distance moved over by substance over distance moved by the solvent. You are given the examples here. So distance moved by from start line to the solvent front is 45, and the distance moved by the food colour is C. And then using that calculation, you have to identify it. So you have to identify the distance moved by the substance, which will be 18, and then the distance moved by the solvent, which of course is 45. So you do 18 divided by 45, and that will be 0.40. So that is an example there. What we're going to do on the next few slides, there's going to be a few progress checks just like this, and I want you to have a go yourselves. So next one here, we have 17.76 as the distance from start line to solvent, and then 10.03 distance moved by food colour C. And you have a go, and I'll give you 2 minutes to work this out. You will need a calculator, or if you're at home, just use a laptop or another technological device to work that out. Okay, hopefully you got the answer of 0.56 because you do 10.03 divided by 17.76, and that's 0.56. Can you please make sure, even though it's 1 mark, always show working out, just good routine, and for when given equations and calculation questions that are 3 marks or 4 marks, 2-3 marks of that are often by working out. Okay, the next one, once again, you've got 2 minutes, have a go at this one, 2 minutes, off you go, now. Okay, hopefully you got an answer of 0.26 because you do 48 divided by 184. Excellent, you've got that, give yourselves a mark. And then the final question, the plenary, I want you to read through the question and have a go at this. In particular, this is recapping all of what we've done so far in the learning session today. Explain how paper chromatography could be used to confirm that this is permitted additive, so added to the salmon colouring. So have a go. I'll give you 5 minutes for this and the plenary, and then we'll go through it, self-assess it, and that will be the end of this learning enhancement video on chromatography. So 5 minutes, go. Okay, your time is finished there, guys. 5 minutes are up. Can you please make sure you've got a green pen or another coloured pen or pencil to self-assess this plenary, this final question. So, answers coming up now. So, the use of solvent or solution of water, any named solvent, that would be 1 mark if you just mentioned that. It then separates or carries colours or dyes. If any mention of 1 would be a 2nd mark in your answer. And then the 3rd and final mark, the 3rd one, the last one, would be match against the RF value. So you're comparing against it, or a known chromatogram, or a similar pattern or comparison to permitted additive or colour. That concludes the video on calculating RF values on chromatography. Thank you for listening. Have a great day. Thank you.